I worked together with Luis in the past 2 years and a half in a research project, NECOS project. Today we have a talk, Transport Network Strategy in Telefónica. Luis Contreras earned a telecom engineer degree at the University Polytechnica of Madrid in 1997 and holds a master degree on telematics from the University Carlos III of Madrid in 2010. Since August 2011, he is part of Telefónica ID, Investigación y Desarrollo, right?
Yeah.
And Telefónica Global CTO Unit, working with 5G, SDN, virtualization, transport networks, and the interaction with cloud and distributed services, as well as on interconnection topics. He is a part-time lecturer at the University Carlos III in Madrid. Before the position in Telefónica, he worked in Alcatel and Orange in Spain, and he is actively involved in research and innovation activities with 60-plus papers published in relevant journals, magazines, and conferences, being regular speaker at reputed academic and industrial events. He is also involved in several research projects funded by European Union. And currently he is working on a Age 2020 project, 5G, 5 Growth and 5G Eve, also with collaboration between Europe and Taiwan in the 5G Dive project. On the standardization arena, he is active contributor of ETF. He authored 5 RFCs, and also with contributions in NET, CITUT, ONF, and ORAN. So a big, short bio. Thank you, Liz. The floor is yours.
Okay. Thank you, Rafael. Thanks so much for inviting me to this session. It's an honor for me to have this opportunity to talk with all of you and, well, to present some of the stuff that we are moving forward in Telefónica. I'm not sure if I will be, let's say, or in other words, in case I consume the time, I will skip some slides in order to allow some minutes for questions, if any. So, again, thanks so much, and let's go for that. So the topics that I would like to talk to you is essentially what is the strategy that we are following in Telefónica in the evolution of the transport network. So I will basically introduce some few words about Telefónica just for all of you to see what is the company and where we are and so on so far, and then we will enter into the matter, the objectives of the strategy that we are following, so where we intend to go, and also an overview of the 3 different pillars of this strategy: the network transformation in terms of architecture and technologies, and so the introduction of programmability as a mean of automatizing all the configurations and all the evolutions, so moving from manual configuration to something much more automatized. And some topic about disaggregation that is somehow related to the evolution also in the industrial ecosystem, how we face the approach to the industry for buying equipment, the procurement processes, and so on so far. And finally, some conclusions. If any of you want to interrupt me, feel free to do so, or we can take the questions at the end, if any. So let's go for that. So just some few words about Telefónica for those that don't know the company. So Telefónica is a global operator. It's present in Europe and in Brazil, mainly. In Europe, in UK, Germany, and Spain. And also we are very much present in Latin America. So somehow the organization is structured in the way that you can see here. In Europe and Brazil form the core of the company, having ISPAM, or Hispanoamerica, as an operational spin-off, including countries like Mexico, Argentina, Chile, Colombia, Peru, and others. Maybe relevant for you to put into the context all this talk as well. You can see here the brands that are behind Telefónica in the different countries. So in Spain and Hispanoamerica, we go with the brand Movistar. In UK and Germany, we are O2, and in Brazil, we are Vivo. That I hope you could be good clients of Vivo, having a good experience with us. So let's go into the matter, and let's start somehow by the end. So what we are doing, what I will present later on. What is the motivation? What we are going in this way, and what are the final objectives that we want to cover? And these objectives are basically related to the programmability, virtualization, and also the overall concept of network slicing. So the need for transformation. What a little bit of history. So by about maybe 5-6 years ago, the company started to envision that there was the need of producing a big change in the network architecture. So the network architecture that we had by that time was not so scalable. Basically, because we have a large number of routers into the network, routers and optical equipment into the network with different functions. But the point was essentially that as long as the traffic is growing, and as long as you have to invest in the network, if you have too many separated functions and too many nodes for serving the network, at the end you have a large cost for upgrading that network. So the idea was essentially to simplify the network. We will see some examples later on, some new topology, and simplifying into access, reducing or let's say concentrating functions in a horizontal way. So essentially putting functions together on the same router, on the same node, and functions like, for instance, the BNG for the FTTH or XDSL access, or a PE for corporate services, or these kind of things, right? So basically concentrating functions on fewer nodes, and also simplifying in a vertical way, so reducing the number of hops from the interconnection up to the cell-side router. So in such a way that one user would need to access content, we could have very few hops in order to get that content. So apart from the traffic growth, apart from the complex topologies that we had at the time, also there was the view that we will evolve into new access technologies, essentially. So there was a generalized, or is now a generalized deployment of fiber, or increasing, and in the case of Brazil, this is happening nowadays. There was at the time the 4G, but envisioning 5G, and now even we are envisioning beyond 5G things. So essentially the idea was to prepare the network for all those challenges. And apart from all these aspects, also there was a change on the paradigms, on the technological paradigms, with the introduction of NFV, the network function virtualization, and SDN, the software-defined networking. So basically this imposed different ways of acting and different ways of deploying services. These different ways is essentially much more dynamicity, much more flexibility, and the need of transitioning from the old manual style way of running a network to something much more automatized and much more flexible at the end. So with all these inputs, essentially the directions were this idea of consolidating or concentrating functions, nodes, and layers, start defining an architecture that could allow this transition to SDN, and also look for a more economic way of growing or of upgrading the nodes, and so somehow trying to break the status quo of the manufacturers, of the vendors, as we knew at that point in time. So yeah, so basically these were the axes. So I will go through them. So what is somehow what we could expect that will be the network of the future, and we are talking future, but this is something more or less close to tomorrow than in a decade. So it's more or less the way in which we are transitioning. So we will have essentially a number of compute facilities deployed in the network, and these compute facilities will be used for conventional cloud services, but also for hosting functions that will be virtualized and that we will, in principle, allow us to have this flexibility and to adapt to the different needs driven by the customers. So we will, the point will be basically the introduction of network function virtualization, somehow having a decoupling between the function and the capacity in the physical device. So just to make this more clear, the point is to change from the old style of deploying a function, a function within a node in a node in a monolithic manner. So you can imagine, for instance, the old way in which the mobile packet networks were deployed, where you have, for instance, the GGSN or the SGSN, and all integrated in a single box, presenting limitations in terms of memory or presenting limitations in terms of throughput, as long as you had much more demand from the mobile users. So the idea of virtualizing functions is precisely to break that problem and to decouple the function itself from the capacity of the node in such a way that we could instantiate different replicas of the same function, the GGSN or the SGSN, in different hardware in such a way that we can grow in a smooth manner. So this is just an example, but the point is essentially the same for any other function. You can think here functions for authentication, for IMS for the voice, for CDNs, for instance, for delivering content. So whatever kind of function that you could imagine. So this is one clear trend, and we are going in this direction for sure. And in order also to make flexible the functions, it's not sufficient to have this capability of virtualizing the functions. You also need to adapt the transport network, the underlying transport network, to that flexibility, because you have to recompose the paths. You have to recompose to reconfigure the ways in which you are delivering the traffic in order to accommodate these flexible demands that are not expected. Note that somehow the traffic patterns are changing now with this idea of having this flexibility, because as long as you are starting instantiating different functions here and there, the sources of the traffic are changing. So you need also to adapt the underlying network to those changes. And for that, what do you need is essentially, in order to make it automatically and flexibly, is to leverage on network programmability, on the capability, essentially on SDN capabilities, in order to program and to reconfigure the network accordingly. And the final step, probably mixing these concepts with some other else, would be this idea of slicing that will be initially demanded by 5G networks, but potentially will be extended to some other services. And in fact, we are doing some work in that direction in ITF, for instance. So just summarizing, and I don't want to spend much more time on this, but okay, essentially the idea would be, in the case of slicing, to create different and adapted and tailored pieces of the network for the different kind of services. We will have services with different characteristics. Here, for instance, I have exemplified a very high level differences between what could be an enhanced mobile broadband slice versus a mobile massive machine time communication slice versus a ultra reliable low latency slice. So for instance, in terms of bandwidth, the MBB would be much more demanded than the others. In the terms of latency, we would require very, very low latency in the case of URLLC. And in the case, for instance, of number of sessions or a number of supported connections, we will have much more demand in MMTC than in the others. So at the end, the objective, the idea is to adapt the network to all these characteristics, to guarantee the SLOs and the QoS associated to them, and make all of them coexist in a graceful manner. All of this, as you can see in the figure, interconnecting spread computing capabilities is spread into the network, hosting different functions, and essentially chaining different kind of services as demanded by the users. So we are in this path. In this way, we are evolving from a triage structure to a per service structure. So somehow shifting the way in which the networks are being architecture, and also transitioning from something more or less static as was before to something dynamic that requires all these automatized capabilities and all this programmability and flexibility again. Okay. So what with these ideas in mind and with these objectives, what was the strategy that we consider for in Telefónica? So somehow we foreseen three main pillars or three main areas. One was related to this idea of simplifying the architecture, reducing the number of hubs and concentrating the functions, and so that we call them the brand of this project was Fusion. So we did this transformation for both IP and optical layers in the network. Also considering not only the simplification but also the adaptation of the equipment to the new challenges. So somehow trying to foresee what would be the new demands in terms of technology. We will visit some of the ideas later on, and so somehow renewing the network, simplifying the network, and preparing the network for the future. This Fusion project was started by that time. You could see in the first slide, 2016, 2017, something like that. And we started in Spain, and we moved to other countries. Also in the case of Brazil, the Vivo network has gone through these transformation ideas, and is now more or less adapted to these new architecture, simplifying things and so on so far. The second idea, the second pillar was what we call eFusion, and the I is coming from intelligence, and essentially is focused on all these ideas of programmability. So how to make the network programmable, the transport network, I mean, because the other parts, the functions and so is out of the transport network. So I'm talking here about the transport network. So how to define an architecture that could allow us to facilitate that programmability into the transport network for all that flexibility that we do foresee. And how to integrate this architecture with the OSS systems, the operator support systems, in order to integrate all these necessary functions like fault management, performance management, inventory, and so on and so forth. And the latest stage is what we call Open Fusion, that goes in the idea, insist on the idea of disaggregation. So, okay, by now we are in the procurement process. The old style also was to buy the complete solution to a given vendor. For instance, just for putting an example, a router. You could buy a router from Cisco, from Juniper, or from Huawei. Now the idea is to transition from that model that is somehow closed to an open model where you could essentially go to the market and acquire maybe the hardware from one vendor and the software from one other vendor, and integrate all of them hopefully in a graceful manner, and basically playing with the pieces somehow. So this is why the example of the IKEA here. Okay, so. Well, yeah, and finally, well, these were essentially the three pillars: Fusion, iFusion, and Open Fusion. Not very creative, but working. So let's go a bit through the technology evolution, and let's talk a little bit about IP and the 5G transport architecture. Here we will list a number of technologies that we are looking for, and yeah, just for you to know. So, okay, we started with that evolution in the architecture. As I told you, this was initiated some years ago. In the case of Vivo, for instance, we started in 2018 for this transformation. We are yet running the transformation process because Brazil is quite huge, and we are yet in the process. But this was more or less started. So the way of simplifying the number of layers and concentrating the functions, that was done. The way in which we are looking, the way in which we are now, is to look what could be the technologies that we could consider in order to face the future challenge in a more easy way, let's say. Okay, so essentially, I will revisit here a number of technologies that we are looking at, and maybe we can discuss if there is some question about this. So for instance, we, for sure, with all this flexibility that we have mentioned before, with this idea of virtualizing functions and deploying functions here and there in a flexible manner, we also need to accompany all this flexibility in the transport layer, okay? So we need mechanisms for steering the traffic in a flexible manner. This is why we have this, we are analyzing these different options, segment routing MPLS, segment routing version 6, traffic engineering, etc., etc. So this is one hot topic, and essentially this kind of technologies will be introduced in the forthcoming years, starting, well, in some of the countries. In Telefónica, we, as I introduced before, we are present in different countries, so the rhythm of introduction of technologies is not equal in all the countries, but we have started to introduce this kind of technologies already in some of them, and we are analyzing the introduction in some others. So this will be, for sure, one of the next steps. Also, there will be some changes on the radio access network. So with the advent of 5G, but not only for 5G, there are some changes in the architecture. Maybe you have listened about these ideas of virtual RAN or cloud RAN, where essentially you break the previously monolithic base station, and you take the different parts of the software, and you can put some of these parts in either in separate monolithic devices or even in the cloud. So this idea of taking the software of the radio and splitting here and there imposes very strict requirements in the transport network in terms of latency and bandwidth, depend on the protocol that you have to support. So this essentially, this evolution of the RAN is also questioning the architecture that we have, and also the need of supporting new protocols in the access, for instance, the eCPRI, but also to support architectures that could guarantee very low latency in the distribution of the information, in order to guarantee that the radio is working properly. Some of those mechanisms that could be deployed in the transport network are the two ones that you can be listed here: the time-sensitive networking and the flexible Ethernet. They are different solutions with the same purpose, which is essentially to provide determinism to the IP network. So the IP network is a network essentially based on multiplexing gain, right? So you don't have guarantees of delay. Somehow you have some statistics, but you will have an effect of a heavy tail in the delay, so you cannot guarantee certain delay. So these two technologies approach differently the point of providing some determinism in such a way that you can guarantee some latency into the network. But the deterministic IP is another approach. This is much more an innovation approach. So these time-sensitive and flexible Ethernet are now available in commercial products. The deterministic IP is a different approach that is yet lying on the innovation field, but essentially try to guarantee the same thing, so to ensure that the in-time and on-time delivery of the information. We are also exploring new ways of encapsulating the traffic. So we talked before about segment routing, for instance, but the problem with segment routing, either MPLS or segment routing version 6, is that you need, depending on the size of the network, and for instance, in the case of Brazil, this could be critical because of the size of Brazil. So depending on the size of the network, probably you would need to stack so many levels in these kind of protocols. So and this has two impacts essentially. So it's less efficient because you have much more overhead, and essentially you it's less efficient in the distribution of the information, for sure, but also has a very important impact, which is that you need to process all those headers, and this can be limited for some solutions from different vendors. So it's interesting to explore the possibility of having similar behavior with new encapsulations that would require less overhead. Aspects like security, and here we could consider MACsec and IPsec, that have very huge impact on the processing of the nodes, especially in the case of IPsec. It could be also needed in the future. The same thing for MACsec. In MACsec, you securize the link layer, so the the node that you are attaching to the transport network. In the IPsec, you can do this at network layer. So a little bit more about technologies, and I will go fast on this. Some more advanced things that we could consider, and we are working on some of them from the innovation perspective, is clearly this idea of application and network interaction. So by now, the applications are somehow ignorant or what is the status of the network, and the same thing in the other way. So the network doesn't know anything about the application. More in these times where the applications are becoming encrypted and you cannot get even a clue of what is the application doing. So the idea of this initiative is essentially to work in how to provide mechanisms for interchanging information between the application and the network in such a way that the network can adapt to the application needs and look for a better experience. Other aspects like application-aware IPv6 networking, who lies more or less in the same idea, but solving this essentially using header extensions for IPv6, hierarchical MAC addressing using the local MAC bits, locator separation of locator from identifier, like in the proposition from Lisp, in such a way that because you already know. You know well for sure that the IP address now contains at the same time the identifier of the device and also the location of the device. So somehow breaking up this could facilitate to, for instance, moving applications or moving users here and there. Information-centric networking, RINA, all the activities in beyond 5G and so on so far. I will not extend so much here, but for sure, if it's something we maybe can clarify later on questions. So what we consider for the evolution of the network in Telefónica is essentially looking at the challenges coming from 5G. We do foresee like 3 waves, and we are trying basically to serve all these 3 waves. So the initial introduction of 5G will essentially look for increasing the capacity of existing 4G networks. So the issue with 4G is that there will be an exhaustion in the capacity because we will not have more spectrum for 5G. So the initial idea would be to deploy 5G in order to provide more capacity to the existing networks. In that case, essentially, we think that we can live with that challenge, essentially growing, upgrading the network that we have, just simply putting much more bandwidth in the NNI interfaces or in the internals of the network. The second wave will come maybe starting next year or in 2 years or so, with the introduction, the generalization of enhanced mobile broadband services that are those that essentially consume a lot of bandwidth, and you can imagine video, 4K, or virtual reality, or augmented reality, and so on so far. Here, the point is essentially, we think we can yet live with this challenge in the sense of probably will be a matter only of upgrading the UNI interface. I mean, the interface is connecting to external equipment, like could be the radio base stations or the aggregation nodes in the fixed network and so. But the very high challenge that we need to face and we need to understand how to resolve is when once the ultra low latency come into the scene. Why? This will be the most challenging thing because they will impose us the need of having that determinism that we have talked before, and how to manage all these latencies, all these delays in a network that is essentially created for multiplexing gains. So how to introduce guarantees on top of that, and potentially this challenge will be only solved by upgrading the hardware platform. So maybe introducing the technologies that we have mentioned before, the TSN or the flexible Ethernet, and this will be a great challenge because basically implies to purchase more nodes, to buy more nodes, and to have large investments. So this is the next challenge that we need to face. Somehow, the steps that we are doing, what we are commenting today, is in order to make these investments lower. So taking the big cake by pieces instead of all the complete cake at once. So yeah, summarizing, all these aspects of technology here, you have essentially the same information as before. So all the technologies that we are looking at in order to simplify the deployments and the evolution of the network. All this hardware related stuff we could associate, or we could consider to the pillar that we mentioned before as Open Fusion, while all the capabilities for making the network programmable and flexible would be lying on what we call before eFusion. The architecture as a whole was the Fusion project, or the simplification. So now the focus is on Open Fusion and eFusion, and we will talk a little bit on that in the next slides. So let's enter with the eFusion, the programmability, and all of this. So why we are deploying SDN? Essentially, operating a network today is complex in the sense that you need to integrate different systems from different vendors. So integration is just a matter of developing the proper plugins and the proper calls between systems. But the point is that whatever a system change, and you can imagine, for instance, that a network node, a Cisco node or Huawei node, introduces some changes in the operating system because new functionalities are introduced, for instance. So you need to somehow integrate again all that node, all these changes, and essentially the point is that you are in a continuous way, in a continuous cycle of integration. So this is quite costly, not only in terms of money, but also in terms of timing, because the developments are not immediate, and essentially the groups within the operators that are deploying things, are developing things, are developing continuously. So somehow probably could be the case that for a new functionality to make, for making work a new functionality, you maybe can take even 6 months, for instance. So having or moving towards SDN, the idea would be to guarantee that all these integrations are smooth. Smooth in the sense that you could use standard interfaces that are standardized in fora like ITF, for instance, or BBF, or this is standardization fora. So with that, we could allow to have an easy integration and somehow decoupling as well the evolution of the network from the evolution of the operating system. So somehow we put into the middle as a standard interface, and we can evolve easily each of those parts. Also, SDN for sure could allow us a network control automation, a better network control automation, because of these programmability capabilities. So this could allow us to simplify complex process like migrations, or whatever operational process that you could imagine, provisioning of services, the commissioning of services. These adaptations that we referred before when we commented the NFV, the network function virtualization stuff, and so on and so forth. Also, once we have this possibility of programming the network and acting in the network in a standard way, somehow we are open the ecosystem. Because if I'm able to manage in the same way a router from Cisco, or a router from Huawei, or a router from Nokia, then I have the total liberty. And with that, I'm more free in order to substitute one vendor by another vendor if needed, because it's not performing well, or even putting in competence different solutions, because I'm sure that doing that and leveraging on SDN, I will operate in the same way the network. So it's also, from that perspective, very interesting to go in this direction, because it gives us flexibility to the operators in order to introduce new technologies, to introduce new vendors into the network. And the very final step would be the introduction, the migration to 5G network slicing, once we introduce first 5G, but also the other services that we expect to adapt to this new trend in the industry. So how we can achieve the SDN deployment? I will be a little bit fast on this, but I will try to comment comprehensively. Okay, so we follow this essentially this workflow. So first, to define some reference models in such a way that we could have a solid architecture in which we can base the mapping of the different components that we need. And by components, you can imagine things like not only the SDN controller itself, but also some complementary modules, like modules for planning the network, like modules for calculating the paths into the network, like leveraging on, for instance, on path computation element technology from ITF, etc., etc. So first step is to define this functional reference model in such a way that we can identify the components that we need. Then to move into the standards in such a way that we could have interoperability among implementations. This is key for making whatever system sustainable. So not having lock-in from a specific solution from a specific vendors. And in order to give a proper message to the market, there is a very powerful tool, which is essentially to go with other operators all together demanding the same thing. And this is precisely what we are doing with this. I will show you later on. Then having proper network abstraction models in such a way that we could consider only the complexity that we need in each of the layers. So not over-complexing the layers, but just concentrating on what is the proper information for the proper services. So going service by service. And finally, having clear what could be the use cases, so not boiling the ocean, just concentrating on exactly what we need in such a way that we can ensure that the different vendors, the different implementators provide the functionality that we require in each of the case. So this is why we are defining this, we are following this use case-oriented approach. So going quickly through these 4 aspects. So in the case of the reference model, the idea is to have two levels of control. One level of control per domain, per technological domain, and here you can imagine an IP controller and optical controller for IP and optic network. And on top of that, a master controller that we call SDTN, and software-defined transport network controller, basically orchestrating both of them. Apart from the optic and the IP, you could consider, for instance, controllers for microwave links, because, well, there are a huge footprint of microwave in operators network, and some other, for instance, controllers for the data centers, and so on and so forth. Here, the important thing to highlight is that the implementation of these controllers is not so much important. Which is important in this model is precisely the interfaces. So ensure that the interfaces are standard, and once you ensure that the interfaces are standard, all these pieces are interchangeable, in the sense that if you take one piece from a given implementation, for instance, let's say Cisco for saying something, and if you are not satisfied with that, if the interfaces are standard, you can take some other, let's say Nokia, and you could ensure easy integration on this. This applies to this level, but this also applies to this other level between the controllers and the nodes into the network. So proper abstraction model. So the idea here is to transition from the old style. Well, we had a number of network management systems integrated with an umbrella OSS, and all of this network management system operating just a small footprint, and basically this being a single vendor implementation. So moving from this idea of silos, essentially, to some other idea where we have a unified orchestration of control management of all the devices with the standard node-bound interfaces for the operating systems, for these ideas of fault management, performance management, inventory, and so on and so forth, and also a standard southbound interface for acting into the nodes, for programming the nodes accordingly. Third, the use case oriented, so essentially defining what are the different use cases that we need to cover. Here examples could be layer 3 VPN, eVPN, traffic engineering, these kind of things. So very atomic functions, atomic use cases, in such a way that through a specification we could deliver to the industry, and ensuring that they can be able to implement. By now, we are doing this exercise. We have defined almost 19 use cases, talking with the different affiliates from Telefónica, and also with other operators we will see, in order to have clearly the ecosystem that we need for implementing. So regarding the action with industry, essentially what we pursue is to agree with other vendors the same kind of needs, in such a way that we can go to the different vendors and say, okay, guys, we need all this to be implemented. So it's not just a matter of Telefónica alone, but it's a matter of Telefónica plus Orange plus Verizon plus TIM etc., etc. So this is somehow to create a critical mass for demanding this in such a way that, okay, we can go to the suppliers, to the manufacturers and say, please implement these aspects. And all this interaction is through this collaboration fora, or well, that essentially are standardization fora and also industrial alliances. You can see here some examples like OpenConfig, ONF, ITF, Telecom Infra Project. This is built by Facebook, is getting much success. So, well, all these collaboration fora, here you can see some information about what is the kind of interfaces that we are moving forward. So I think very briefly commenting this is insisting on the same topic, just to mention there are, for instance, in the specific case of SDN, we from Telefónica move and release within the framework of Facebook TIP. Very recently, I think 2 weeks ago, a white paper called MUST, Mandatory Use Case Requirements for SDN for Transport, that is publicly available, and you can take a look, and it's done in collaboration with so many operators in the world. So it's a clear example of what we are intending to do in this strategy. So let's go for the last part, I think more or less in time, which is the open networks. Okay, so we have talked about the transformation, the architecture reshaping, let's say. We have talked about the intelligence, the programmability. Well, just one aspect regarding this point of intelligence. So once we have these programmability capabilities in the network, with the possibility of acting into the network, then is the point when we can start to introduce this intelligence that we refer in the name through actions through artificial intelligence or machine learning or whatever, because we have somehow the way of automatizing everything. So it's just a matter of closing the loop. So as long as we can program the network, as long as we can get the information from the network, we can start adding this intelligence, these processing capabilities in order to somehow close the loop and start doing actions into the network. Important detail that I forgot to mention. Okay, so we have fusion, we have iFusion, now will be open fusion, the point of open fusion, this openness of the network. Essentially the idea is to have a fast way to innovation, to be more efficient in the network deployments, and also to build a more stronger ecosystem, which is not an easy matter. So what is the purpose of this open fusion trend? Essentially to enlarge the scale of economy. So essentially allowing other actors to enter on this market. So either implementators or suppliers of operating systems, suppliers of hardware, and essentially some other suppliers that otherwise could not have an easy way to access into this market. Open the market to these disaggregated elements or to the pieces in such a way that you could cherry picking whatever is more convenient to your needs, and not rely only on what all vendors are proposing. And essentially also important these days with all these political issues that are happening, also to guarantee the supply chain protection and let's say ensuring that there will not be same things happening with some vendors and so somehow the operation can still live if some vendors have issues, political issues. So what could be the objectives? And here you can see like two different approaches or two different views of this openness. One I exemplify in two cases, for instance, in the optics or in the IP and so. So for, somehow, in some way, the idea of this openness would be to guarantee common interoperability, which would be something more or less horizontal. Here, the example would be that you could consider the railways as a common substrate and running on top of that different kind of trains. So the same idea would be here. So having different hardware substrates, so the same hardware box, but running on top of this hardware box different operating systems. For instance, you could migrate, you could upgrade from one operating system to another in case there are bugs or in case whatever issue. So somehow decoupling the hardware from the software, from the operating system. Also in the routers, in the transport nodes. So this is one approach. The other approach, exemplified here, is essentially to the example of the PCs. So essentially you can pick and choose different elements from different manufacturers and integrate all together in order to generate a product, let's say. The same idea will be here. So you can pick and choose hardware, software from one implementer, from another implementer, and essentially create your own hardware. This is not new. This has been done in the past by these big players like Facebook or Google or so. The point here, but this was done essentially for the data center ecosystem. The trend here is essentially to move this also to the telco networks in such a way that we can make it more sustainable. So this is somehow the path of the evolution. So we are transitioning from a monolithic solution where whatever vendor, Juniper, Cisco, whatever, provided the software, the hardware, and the ASICs, the CPUs or the network processors inside the box. This started to move let's say in a middle step, what was essentially to deploy proprietary hardware and software, to take into proprietary hardware merchant silicon from very well-known manufacturers like Broadcom, for instance, but integrating in a proprietary hardware and a proprietary box, plus a proprietary operating system. This was a very first step. And the final step, the more open situation, is this, when you essentially could integrate pieces, the processor, plus the hardware, plus the software, and somehow opening all the ecosystem. So I should confess that this is not an easy way, but we are pushing on this direction because we think that is the way of guaranteeing sustainability in the future. So I think I will skip this for brevity. Let me just to mention that in this direction of openness, what we are doing, and you can see here on the left of the slide, essentially what could be a simple topology of a network in Telefónica with 5 hops from the interconnection up to the essentially router. So what we are doing is essentially moving this idea of openness to the different RFQs that we are putting in the market for upgrading the network. So this is more or less the status. We are starting to ask these functionalities actually in the industry. So this is not paperwork, is actual change that we are trying to promote. So I will skip this for optical. I think it's more or less the same thing. So conclusions, and then leaving some time for some questions, if any. So the point is that we operators are looking, we have an eye on what will happen tomorrow, but we have also to keep an eye on what is now happening and what was happening in the past, because we essentially cannot decommission all services. Maybe I'm not sure to what extent you can believe me or not, but we have yet, in some of our networks, we have yet frame relay interfaces or ATM interfaces. I mean, very old technologies, and we simply cannot decommission it because we are impacting a customer. So we need to maintain the past, but thinking on the future. So the point is this: new services and technology paradigms are coming. We need to face them, but we need to also to maintain the legacy, which is quite challenging and very costly. Sustainability is key for surviving in this changing environment, and this is why we are moving in this idea of fusion for simplifying the network, eFusion for getting intelligence and programmability, and open fusion for making let's say, having a more cost-efficient solution for the network. Finally, just to mention that this transformation process overall does not only impact the network, does not only impact the operator, but also impact all the entire industry from the users, because you become used to consume different kind of services, and so you are demanding this quality, even you could not foresee what is behind. but also for the manufacturers, because we are changing also these models, these business models, and we are start looking for different ways of approaching the market. So there is my message here, just for finishing, would be there is a very interesting change of the paradigm now in the industry. So for the students that are now finishing, could be quite challenging to start looking at these new companies, let's say, that are emerging in these open environments. Also, these other players like Google or Facebook that are also entering into the networking part. So quite challenging and quite interesting moment, I think we are. Critical for the operators, by the way. And that's all from my side. Muito obrigado. Espero que vocês tenham entendido un poquinho.
Obrigado, Luis. Very nice presentation. It's always good to see how the operators are facing the problems, the challenges we have nowadays. Several questions come to my mind. Earlier, like around 2008, we started with this topic of software-defined networks, and then we see now the operators deploying these closer to the end customers, and maybe mainly in the edge, offering services. So it took quite a long time, more than 10 years, to have this research coming to the real arena, being implemented in companies like Telefónica. So one question is, like, we are here in a university and we have some freedom to do some research and things that will not be immediately deployed. So I would like to hear from you, from your experience, what are the main topics now? You mentioned some of them during your presentation, and how do you see in 10 years from now the results coming out of this research and being deployed in this horizon, like these 2030 networks that we are starting to investigate now?
Mm-hmm. Well, we could differentiate just thinking loud and quickly, different aspects. Looking at data plane, there are very interesting propositions even from this work from ITUT for different use cases. For instance, for guaranteeing this in-time and on-time delivery, that is clearly probably very much dependent on the hardware itself. So how do you manage the queues? How do you prioritize frames here and there, and so. But also some other propositions that play with, let's say, at higher levels, at protocol level. And there is, for instance, a very interesting thing, which is called, I don't remember now the name, but essentially the proposition is to code differently the content in such a way that if you have to discard content, you can select what parts of the content you can discard. So what are the packets? Or in other words, not all the packets convey or carry the same kind of information, the same type of information, such a way that you can somehow play with that in order to guarantee a minimum, while if in case of congestion, you can discard things. And so this is, I think, interesting. There are some other propositions at data plane level, evolutions of multicast, and so. This would be a data plane level. The point here is to, in data plane, to make this cost efficient, because you can imagine you will not upgrade your network in one pass. So you need to coexist with what was the legacy network and make interoperable all this stuff. From the control plane perspective, the evolution now, as you mentioned, it took a long time to start introducing programmability into the network, and I think that the main reason for that was not operational at all. So, for instance, thinking in OpenFlow and these approaches was not actually operational in a real network. So this has transitioned from that, let's say, very granular programmability to something much more high level, where even you have control plane yet in the nodes, and essentially what you are doing is configuring the nodes for acting and reporting to the control plane. So we are introducing now because operationally is the time for introducing it. There are the tools and there are the models for doing that. Because without the models, again, we would need to have this integration, which is very costly. So in the future, what I do foresee with these paradigms like P4 and all these stories, the key point here is probably to make it scalable and to make it operational. For sure, potentially we will go more and more and more on programmability. We will be more and more on this idea of closed loop automation, artificial intelligence, and so. The point is to make it operational. So we have the tools, probably can be improved for sure, but the make is how take them and make it work in an ambient, because you cannot forget that an operator is not like a lab, in the sense that you have penalties and you have regulators behind, and you have to comply with some service, and essentially the customers are paying you some fee, you have a contract with them, so you have to guarantee the service. And this is the key, how to make it operational in such a way that can be introduced in a smooth manner without impacting regulation, penalties, customers, etc., etc.
Very nice. I think we can close. You have to leave to this IETF meeting now. So thank you very much. I hope to meet you soon somewhere after this COVID-19. Stay healthy and keep in touch.